or something should be different. If they were the same, it would debunk the globe or something.
Well, there's the thing of doing the Eratosthenes sticks and shadows with moonlight instead of sunlight.
Yeah, that was
if you do it with moonlight and you get the same angles, what is this? Moon also 93 million miles away? Ba-dum-psh.
Yep.
Yeah.
Of course, all it has to be is far enough away to produce parallel light, and it doesn't. The moon's not quite far enough away to do that as accurately as the sun, but it's really far away, so it does it pretty well.
But why would it give angles of 93 million if it was only a quarter of a million?
I don't know what you mean by angles of 93 million. What do you mean? What matters for the Eratosthenes experiment is that the sun is far away, and the Greeks were well aware that the sun is very far away from the Earth. That's obvious simply from the fact that they knew pretty well the distance to the moon. That's just a parallax measurement. And then they knew that the sun was much further away than that because of looking at the phases, working out the triangle. When the moon is at first or last quarter, you know that the angle between you and the moon and the sun and the moon is 90 degrees. So you can work out the rest of that triangle, and you can show very clearly that the sun is much further away than the moon, which is itself very, very far away. And so the light coming from the sun is parallel for all intents and purposes. And the Eratosthenes experiment made that assumption because it was well founded.
Okay. Well, I mean, whether you make a judgment call that an assumption is founded or not, I guess would be subjective. But so you're saying the moonlight is also parallel?
That's pretty close. I mean, it varies. It varies by what is it? A couple degrees, a degree or two, I think, from one side of the Earth to the other.
What's your account for those, like like when the sun's sort of goes through the clouds and it sort of like the rays sort of like split up?
Yeah, that's the railroad track effect. You guys are good with that. You understand that.
Yeah, but I would like to hear what your explanation
well,
is.
The thing you'll notice in all those pictures, of course, just like with shadows and everything else, the critically important thing is that those rays all lead back to the sun, which they do. It is true that it's really psychologically appealing to think that those rays are coming kind of straight down from the sun, but they're not. They're coming toward you. They're coming almost exactly toward you. In fact, many times you can see those rays passing on all sides of you. Some rays will go up, some rays will go down, but they all converge back at the sun. All of the rays that you see in the Earth's atmosphere are parallel to within a tiny fraction of a degree. They're just passing you at different distances.
So
and in
even
different
though
places.
they look like they're like fanning out,
Right.
they're actually straight.
Well, they are fanning out from your perspective, just like a railroad track does, right? Railroad tracks are parallel, but they look like they fan out too.
Oh, now I get it.
If only that were true.
It's like reverse psychology. No, okay.
But not to get into a whole meta thing, John, but I mean, you're saying that as if you're here to like try to just like teach or write the way for people, but obviously you're very interested in the topic. So it doesn't really fit psychologically that you would just be like this like virtuous person that's just trying to help these people that don't think something you think is right. There's obviously something more, but we don't have to get into that whole combo. I'm just saying
That's okay. No, my wife says the same thing to me, right? She doesn't understand why I do this. And I started doing it. I think it's a different thing now. There's a lot of motivations. First of all, I started doing it because I feared, and I still do fear, that it's pushed by the same bad actors who push Pizzagate, all of the conspiracy things. They're all intended to make us fight with each other, to make us not believe authority, to make us not believe academics, to not believe experts of any kind, to not believe government, to not believe all of those things work very much to the advantage of people who I think do push these conspiracy ideas. So that's why I started it. I just wanted to stamp it out. I continue to do it it partially because I think there's usually people in the audience who need to at least hear both sides of the argument and make their own judgments. Hopefully, if they're rational people, they'll make the right decisions. But there's also, I mean, frankly, the most important thing about it is it's made me look at a bunch of things. You guys have stimulated me to look at things that I hadn't looked at very carefully. One of the most, and I'll just give you one example, then I'll stop yammering, sorry. Aries failure. That's one thing that I had never heard of before. And looking into that has been a true revelation for me, understanding things that I never really did fully ground before, and just the whole history of 19th century physics that led to relativity is totally fascinating. I'm doing a room on it tomorrow, the first of many rooms that I'll be doing on Clubhouse tomorrow.
All right. I hear what you're saying. Yeah, I followed all that. Okay. Well, I don't know if we want to continue on this line or whether if I respond or we keep going on it. Because like I said, I brought it up, but it would shift from the topic you guys were on before. But
yeah, I'm not eager to continue talking about all of that stuff. I really do like talking. I like it when we come up with a topic where we can present evidence and go back and forth. I like the topic about the latest thing is just the spherical nature of the Earth. I do think it's an interesting thing to ask yourself: is your lack of belief in the globe Earth, is that because you, well, first of all, can you imagine a sphere? Forget about the actual Earth. Can you imagine a sphere so big that it would really, literally be flat for all intents and purposes, all kind of local daily purposes? And if you can imagine that, is your antipathy for the globe Earth just a result of the fact that you don't think the Earth is that big, or is it something else?
yeah, well, I hear you. I mean, that would be a separate thing. I mean, I could respond to that, but I guess, well, I mean, first of all, I guess to cover that a bit. I mean, of course, I mean, that's a whole topic in and of itself. I know you might not be targeting that to me. If you're targeting that to somewhat other people that may have like,
right, sorry, not just you specifically. That would be a topic I would be really interested. I don't know that there's much interest in talking about it, but I really am genuinely curious. Seems to me that almost everybody should be able to imagine a sphere that big. And then the question is, so what is it about the Earth? Is it just that you don't think it's that big, or what?
Yeah, well, that's just one factor of many. That's the thing. It's just one factor. I mean, the size of it, and then the curvature rate. I mean, the thing is, the old we see too far. So we could get into all kinds of refraction and seeing around curves and things. But I mean, if you just go out and observe the Earth, it's planar. You see extended planar, and you see objects far beyond what the curvature should allow for. So whether it's too big or not, we're viewing the Earth as an extended plane in terms of the observations that can be seen. And of course, we could debate that. It's just a huge can of worms, basically. There's many angles and components to it. But I think if somebody were just having a very remedial, like, oh, I should see curve out my back door, of course that's false, because of course, I mean, I understand thoroughly the size of the Earth, what the curvature would be. And yes, I would agree with you. In general, if we were on a sphere of that size, in general, it would appear more or less planar in a local area. However, we wouldn't be able to see too far. We would be able to not see around the curve. But like I said, that's an entire series of arguments in and of itself. But I don't think that's all of what's fueling all of this. Is just somebody thinking it doesn't look like a ball from the ground in some simplistic manner. Some might feel that in some ways, but I'm just saying I think there's a lot more to it than just that.
Yeah, I do too. I agree. I think there's one other thing that it's about. I think that's probably the more important thing.
What is that?
Yeah, I mean, there's so many aspects to this whole topic on multiple levels. Yeah, there's the sort of physics side. There's the sort of even emotional belief side. That goes for both sides of this discussion, quote unquote. There's all of it. Yeah, some people have more of a propensity to, want to kind of believe others in terms of whatever it may be. That part of it versus the like physical, tangible part. But yeah, I mean, there's a lot. One thing I wanted to say just about the, being here kind of thing. I was just going to say real quick with that, because there's many tributaries to to run off from everything there. But I was just going to say that there are many, many globe earthers in this community who are some of the ones that are very, very knowledgeable too. They have college degrees, they're very educated. And it's just interesting because they say so frequently that one thing about this community is that it made them think. They've learned so much. I mean, even Scott Veach, who I don't know if he has a master's or a PhD. I don't know his degree. His father was an astronaut. If you probably know who he is, but yeah, his father was an actual astronaut or whatever, claimed to be, alleged, etc. And he's in these communities. We've talked to him for years, and he also writes. He writes for like Netflix and stuff. He does like TV shows and movies. He's like a writer. But anyways, my only point in bringing him up is just to say that like he's mentioned that like he said something like he's learned more in this community than he did in all of his years of college or something. So now maybe I shouldn't put that quote right on it, but something to that extent. And that and so many people say that they learn so much, and these are educated people, as it were. These are not sort of these are people that have a lot of knowledge and things. So I guess I would just kind of what I was going to say from that part from before is like, what do you think it is about this topic that would bring such an interest and an attraction? Because if I said, hey, clouds are purple elephants, and that was my theory, and I was going to go say that, do you think I would get like PhDs and very educated people that would be coming in being like, oh, I've learned so much from this clouds or purple elephants or clouds community here. Oh, I've just learned, you know what I mean? So like, what is it about it where there's such a richness of like intellectual depth?
Yeah, no, it's a good question, and it varies. I mean, I think for a lot of people in the flat Earth community, I do. I'll just confess, I find a lot of people, I don't quite believe that they really believe the things they say, that they really are just kind of trolling because it's a convenient thing. But then there's a lot of people, and I think Alan is maybe a good example of this. He's the one who turned me on to. Well, actually, I think I heard about Aries failure before him, but it was in talking to him and hearing the things that he said that made me really look into that a lot more. And I now have a detailed understanding of a thing that I didn't even know about before. One of these days, I need to have a talk with Alan because he's got it wrong, but he really does. I was listening to a thing he did the other night, and it's really good in the sense that he has command of a lot of the facts. He just misinterprets some of them. The most important of which is the idea that in the relativistic view, the Earth is still moving, and there's just a correction factor. But we don't have to get into that either. But it's a good example.
What got me kind of walked into it was
and
just,
now, John, can somebody else talk for?
I wasn't just talking. There wasn't. Just a second, hold on. I was going to bring with John that there's so many. It seems like flat Earth and the federal community starts out fighting every single thing about established science or the indoctrination that we all go through when we're taking science classes and getting PhDs in certain disciplines of the physics or science community. Everything that you bring up is a whole nother level of topic of science. We're talking about entropy. We're talking about mechanical physics, astrophysics, quantum physics. I mean, every single thing is brought up. Magnetism, motion, Newtonian mechanics, Einsteinian theories. I mean, optics, refraction, diffraction, everything. We have not touched anything that we go over in first or second year physics. But the thing I liked about it, I think John will probably back me up on this, is that when we have these discussions, we have to back up what we're saying. We can't just say, hey, I learned this in school, I got an A on that test because I knew the answer. But why is it? How can you prove that? Or how can you show evidence for that? Almost like everything is using the scientific method to say, even though you learned it, how do you know it's true? And we have to go back and now show substantiate evidence for all these ideas and theories, and that's what we're all doing. So I've never could apply any of these things with regards to gravity. Well, some things with gravity and some of the physics I took in aerodynamics, but most of the other topics that weren't related to those topics, I mean, I would never have a clue. Like the refraction, I never got into refraction or optics. Now we're actually talking about how that works and what it means, and Snell's law and diffractive limits and Rayleigh criterion, all these things, and then we talked about even some of the foundations of physics, like entropy, how that was misused by Nathan and QE. That's what really got me into this whole topic.
Come on.
I know, but it's a mass dump. John did a little bit. I want to do a little bit too. But now that's why, Gio, I think it's been great. I love being here because it makes me think, makes all of us think, and makes us all go do research, open the physics books, learn things, maybe understand things in ways we never did before, and come back and have a discussion about it. That's pretty much it.
Okay. Yeah. I mean, it's fair to say, like, if there was a community or people that were saying clouds are made of purple elephants, if they also were talking about entropy and other things, I guess it could make sense. You'd be like, hey, these guys are talking about these purple elephants. I don't agree with them that the clouds are purple elephants, but I really like this other topic or that one, or I learned about this or whatever it may be. I get kind of maybe is a somewhat explanation, but I was going to say something kind of funny. Like, let's say, let's say you when you pass away, whenever that is. Now, I know some people think it's just lights out and there's no life after death, whatever. Let's say there is life after death and you're at a higher state of awareness and things. I'm not trying to say the whole thing of being judged by God. I'm just saying if you were in a state of awareness where you could see your whole life and see the whole thing, like, at that point, I guess just for your consideration, would you be like, well, let's say you knew the truth then too, the full truth, everything at that point. Would you look back and be like, okay, I see. So I was so interested in that community and everything because there was truth there. There was something that was foundationally true about what they were saying. And that's why it had all this energy and there's such a rich community and years. That's why, rather than, oh, okay, yeah, they were wrong about everything. You in the position of you or whatever, you were right about everything. They were wrong about everything. But it just happened to be this community that talked about the topics. I mean, I know that's all kind of rhetorical. It's all kind of generalized, but yeah, it just, I don't think you could create a community that disguise purple elephants and have PhDs coming here and debating it. It's just.
Before I forget real quick, I want to respond to that because it's actually some good points that made me think for a second. No, I think it all stems from this like internal desire to help and teach. Maybe I think we're all kind of like, if someone doesn't know something, we want to help them. We can't help them unless we actually know that particular topic. So when someone's like, it's why I get thrilled when I work with kids, they ask certain questions. And in fact, I was over talking about, someone asked me how far the sun was going down, and it was a half-lit moon yesterday, and people said, "Oh, that's interesting. Well, why is that shadow? It looks like the moon, sun's over here." It was all like a astrophysics type of a question, and so I kind of went into Aristarchus and Eratosthenes, and the kids were really super interested. One kid, "Oh, I don't like astronomy. I don't want to hear it." He walked away. The other, "Yeah, I have a telescope at home. My dad has this." Tells me we look at the moons and the stars, blah, blah, blah. So it's kind of cool explaining these kind of things to people. I think when we come here, they're all like a bunch of, in our minds, in my mind, I don't think I'm wrong about most of the things, even though I'm challenged all the time. I do think it's a bunch of people that don't know these topics, never studied it. And I get a thrill out of trying to help people understand things. I mean, there's a certain amount of sense of accomplishment when someone kind of gets the reasons that that things happen in the world and the things around us.
Let's just give a good example of that. I mean, one of the things that I probably wouldn't have done before, I've gotten really interested. I have a Nikon P950 now that I probably wouldn't have if it weren't for this community. Right. And I use it to, take pictures of the sky. And the other few days ago, you may remember the crescent moon was right next to Venus in the evening. So I took pictures, just of the two of them together. And then I zoomed in on Venus, and I was surprised to see that I could see the phase of Venus. I actually took a picture of it, and it's now in last quarter. It's on its way to new Venus right now. Just as it should be, given where it is in its orbit. And it's interesting, too, because I don't know if you see those pictures that people do where they hold up a ping pong ball and show that it's the same phase as the moon in the sky because the sun's light is coming from the same direction to both of them. The light is parallel at both the moon and the ping pong ball. That's why it lights them up the same way. And So you take that, and then you take the Venus and the moon. There's a situation where the moon was almost in between us and the sun, so we were just seeing a crescent. But Venus was about 90 degrees off of the sun, much further away. And so they're right next to each other, showing different phases because of the fact that the sun's rays aren't parallel coming to the moon and Venus. They're far enough apart. And I just like, stuff like that. I don't think I wouldn't have gotten so kind of excited saying, here's another situation where the model just does exactly what you'd expect it to do.
Never
so that's the kind of thing I really like.
Never would have noticed those things. I saw the same thing that evening. The other I have a crappy little telescope here, right? But I knew it was going to be in some phase. But I didn't think about why isn't it the same. Now I think about why it's not the same, because the rays are not parallel. It is much further away, and it's in a different position with respect to the Earth and the Sun and the Moon.
Yeah,
so I don't know.
I get excited about. I get like nerdily excited about stuff like that.
I geek out on all sorts of stuff like that. All sorts of topics in my life I do this with. But that's why we're here, Geo, and everyone here is not. No one's dumb here. They're all pretty smart people. They all have a lot of intelligence. They have great arguments, and they're questioning everything. And that's what science is really about: questioning everything. But the fun part comes is because they're so like a Jeremy or somebody is so challenging all the conforms of science and physics that it becomes this debate, a friendly debate where they're holding their ground, we're holding ours based on what we've learned, and then we have to prove to them, and they're trying to disprove our proofs or our evidence, and it becomes a really interesting discussion. Even though I don't take any, I don't take it personally that I'm insulted or they're trying to say I'm wrong and I'm an idiot. That doesn't matter to me at all. It's just fun having the interaction. Everyone does it fairly respectfully. And I'm learning along the way too. Even today, we're talking about molecules and atoms and structures and how the electron microscopes work. And that's interesting stuff too that I don't know a heck of a lot about. And we're learning as we go together.
Well, I hear you.
Yeah, go ahead, Joe.
Well, go ahead if you want to go first.
Well, I was just going to say a lot of the things that I think has been the most exciting for me have been not so much the flat Earth things, which I do. I mean, I just candidly, one of these days, I still hold out hope that I'm going to open eyes to that. But the geocentrism thing is a completely different ball of wax, right? Civilization got rid of the flat Earth thing 2,500 years ago, but geocentrism was and is still at least a defensible proposition. And I think that's where Alan, I may be supposing too much, but I think he's less of a flat earther than he is a geocentrist. And that's what makes, I think, a lot of his arguments particularly stimulating for me, because you can make really good arguments for geocentrism, especially ether-based things, whether we've shown that ether doesn't exist, etc., what all the experiments of the 19th century meant. And so that's what I'm really getting into.
Yeah, well, I was just gonna say, I think to Zanik, like the thing of, Zanik, the thing is though, like this is like there are places that you could go teach quote unquote science all over the world. You could go to places and teach children. You could teach whatever. You could do online classes. I mean, if you're really into science and entropy and all this, there's a million places to go talk about those topics. But you're here. You know what I'm saying? So that's one thing. I mean, now you could say maybe there's not as raging debates in other areas. Well, then what makes this such a good raging debate? Or as it were, discussion. So it's sort of like, I guess it goes back to like, why are we here? And I mean, like, why are we, right here on this live stream right now kind of thing? Or why have we been involved with each other for a decade or more? A decade or less, I guess, if some people have not been since that long, since a lot of this started erupting around 2014, 15. So I guess it's kind of that open-ended question, but it's like, okay, are we here because what many of us are saying is true in terms of, one or more of these factors, or are we here because, I guess from your perspective, a bunch of people are wrong and it just happens to be this incredibly intellectually rich community where you are finding your intellectual match in the discussion rather than going to a NASA Discord server or some other place that's just like, this is not really, You know what I mean? So it's like, it's kind of strange. It's like you're meeting these people that are like very highly intelligent that you want to debate with. Like you're choosing the people here, as it were, just in this community rather than going somewhere else. You know, so you're choosing here, like, oh, you like you guys are the smartest I want to debate with, but you think we're totally wrong, or you think they're, you know what I'm saying? So it's like,
I have an answer for you. It's a great question. I was thinking about like why would I pick this particular area, this group of people, or group to work with? Well, you might think of like the analogy of teaching children, like shooting fish in a barrel. If shooting the fish and killing the fish is your goal, to just educate them, and then otherwise you're on the hunt, hunting tigers. They're running away from you. You have to have some skill. That might be an interesting analogy, but I absolutely think we're right about what we're talking about and what we've learned. I don't think there's a huge conspiracy theory that has put the wool over our eyes and convinced us to think that the Earth is round from some kind of control goal. But what I do like is that there's a lot of intellectuals in this group, as you said. I don't think the knowledge is the same. And so I'm challenged on something that I think I have knowledge, they don't have knowledge. And so it becomes a really spirited debate where I have a position of having, even though I have the knowledge, I still have to convince them that their knowledge or their lack of knowledge or whatever their position is incorrect. And it becomes a very spirited, and it forces me to have to learn whatever I'm trying to propose or talk about in a much more complete fashion than I've probably learned it or understood it even in the past. So that's why, because the audience, your group are smart. They have a whole different knowledge base than ours, maybe opposite knowledge base in some areas. So it becomes a very motivating environment for us to go back and double check, relearn, maybe expand the knowledge in that particular area, and then present it to try to it's like almost like a debate forum. Like it doesn't really matter what the topic is. It's like you're learning how to actually discuss things and debate things with your knowledge and your evidence, and present it in a way that actually can convince them. Now, I've never convinced, I don't think, any flat earther that the Earth is round. But along the way, I've learned a tremendous amount about many subjects in science and physics that I have long since forgotten or never even learned about since college.
All right, perfect. Can I jump in now, Zanik?
Well, that was just the conversion rate is so low for you guys. No offense, it's like abysmal. Like you're getting almost no one. Like I guess the not final experiment thing maybe sort of got Jaron if he's confused or whatever, conflicted, whatever he's going through. But that's like one, maybe ranty. It's just like so few.
Yeah, I
so
agree.
Just that point of it, like the idea of like this, like motivation of righteousness or really wanting to help these people that have wrong information that you think or whatever. I'm just saying, like, if your conversion rate is so low, it's like that motivation's got to be out the window unless you're just cool with failing indefinitely.
I think that's the fail. I think the failure is not so much whether I convince you to be for you and I, I think you're smart. I have a lot of respect for you. I don't think I'll ever convince you that the Earth is anything I talk about. But I do enjoy the discussion. I'll put my case, you'll put yours, and you talk about this electric universe and all these other things, and the hyperbole, this, that, and the other, hyperspace, whatever your descriptions of the electric universe is. And it's interesting to hear your take on that evidence. But it doesn't matter whether you're going to be convinced or not, or converted. It matters that we're both making the effort to try to talk to each other about our ideas and theories and hear each other and then discuss them in a forum where there's it's safe.
I hear you. Let's let Rob get in. He was trying to get in, but I just real quick, like the only thing is that if I was to use the flat earther, globe earther dichotomy kind of names, in general, like globe earthers come to flat earthers. Flat earthers don't really go to globe earthers to debate. So I'm just saying in general, but yeah, what that means, you can think about what that means too.
Because a lot of the times I do get to talk. Thank you, Gio. I really do appreciate you letting me get back in here. What I'd like a lot of these globe guys to understand is, like, some of us are in our 30s and 40s that are now calling ourselves flat earthers. We were all taught that the Earth was a globe, and we all believed it until we started investigating some other things and finding out people do lie, and people do shit just for money, and people do shady shit. And then we start doing our own experiments. We go out and buy our own tools. and we start to see where the lies are. And then we come here to convey what we've experienced, and the Globers don't seem to want to do the same work that we did. Thank you.
What work is that?
Yeah, and I think there are lies and there are people making money. The only question is who's lying, who's making the money for lying.
Well, like I said earlier, I'll try to be really fast with this. I tried to present a thought experiment, right? We won't get into that. But Will Duffy just spent like 250 grand going to Antarctica to look at the sun. I got a thought experiment that we could turn into a real experiment and probably only cost us maybe 10, 15 grand.
What's that thought
That,
experiment?
yeah. I'm not getting right back into it right now. I tried presenting it earlier. It was told it was impossible, so I let it go.
Can you
Thank
give me a
you.
high level? Just
So-
like a couple words? No?
Yeah,
No,
and I mean, I'm curious because I think what Will Duffy did was really good. He took kind of the central claim of flat Earth and checked it out.
So
now,
I have a
It's
question
why-
about that.
what is
Hold
your
on,
what's
hold
your
on.
suggestion? Yeah.
Okay. I strongly do not think it is a central quote unquote claim at all.
Thanks.
In fact, someone came in the other day. His name is Ron. He's been involved in this for many, many years. Back on the 24/7 Flat Earth server, back when that was the main spot we all hung out on, for years and years and years, debating it every single day and everything. And he came in. He's like, "No, dude." He's like, "The 24-hour sun was always kind of a side thing, like the Antarctic 24-hour sun. Yeah, it was a thing that people discussed. It was kind of one of the bullet points because there was a lack of evidence for it, and there was this, and that, all of that." But I'm just saying, it was not like the way that that's trying to be promoted now is if it was some central thing that was, it's just not the case. Like
Central is
it's like,
probably the wrong word, but I mean, a lot of the leaders in the movement just said that it was absolutely something that the flat Earth couldn't survive, which I think is weird because as you probably know, I like to point out the flat Earth model, the Gleason model, predicts a 24-hour sun everywhere, always. So I think and Shane's model predicts not only a 24-hour sun in Antarctica, but the correct 24-hour sun. So it's kind of funny in a way that it was so many people really said that that's absolutely can't happen. I think, I don't think you can deny that. It might not be a central claim of the model, but it was absolutely put forward as a deal breaker for the model.
maybe only for those people pushing maybe only for the ones pushing an AE map with that particular sun path, with that particular idea.
That's true.
Yeah, it's just those
That's
folks.
true.
Which,
Yeah, I wouldn't.
I mean,
Can I ask Rob a question to follow up on what he said? Because I was curious about that. Rob, you said that you don't think other people have done the work you did. I understand that there's a experiment that people haven't agreed to, but that's obviously not the work that you did. Is there, when you said that, were you thinking of something else, some other work that you've done that you think Globers are not willing to do?
Yeah,
John, it's that kind of interest, John. It's that kind of interest that's just like, what is that? You know what I mean? Like Omnivore's like, hey, is there something I could do? You know what I'm saying? Like, no offense to Omnivore, it doesn't come off as a fully confident position.
Got it, bro.
So
Curious. Everyone has an idea. I want to hear what it was too. Just high level, Ron. Just in a few words. What was your experiment? What was your idea?
Yeah, totally. Let's hear it.
But I want to know, before we do that, I want to know what it is you think he's already done.
Maybe
Stop
he can do
talking
both.
then. You want to give me just 10 seconds?
Yeah, your mic is really, really rough, as you know, but it's hard to hear when you're getting in, but because it sounds like a muffle. But if we leave space for you, we can hear you. Go ahead.
How's that now?
Way better.
I can't hear any of you very well because I'm on my phone. So just give me 10 seconds. I'm just gonna produce the thought experiment one more time for Omnivore who wasn't here. Is it possible in reality to create a horizontal concrete slab 400 meters long, 1 meter wide, horizontal. Thank you.
Okay.
So,
and
but that's not the work that you already did. That's something that you think we could do.
Yeah, okay. What I did was I matched an auto level and a water level, and they were identical every time. So if we want to scale it better, a 400 meter water level with a concrete slab that's measured horizontal with the most accurate tools you can find. Instead of
Okay.
spending 250 grand going to Antarctica, spend 50 grand and do my experiment.
Would your experiment?
Thank you.
Hold on. I have a
So
quick.
I think I
really-
misunderstood. I think I misunderstood you. I thought that you had said that you, as a flat earther, had done some work that you thought Globers were unwilling to do to get to where you were.
Okay,
I
maybe
didn't
you
realize where
misunderstood me.
Okay, gotcha.
I have something for you that you may not have thought about with that whole concrete idea. Are you pouring the concrete to try to make it flat and making sure it's flat along the way, or can we take concrete blocks, stack them, make sure that they're all perfectly square, and make them for a quarter mile long? By the way, you know I'm going to follow. You know where I'm going with this. We already have a structure that
You
has
can
been
go
forced-
wherever you want with this. I just presented
Hold on.
it.
Let
That's
me finish.
it.
Let me finish real quick. I'm almost done. So we've already done this. Humanity has done this in a few structures. One called Slack, one called LIGO, and there's a few others. But Slack, for example, is 2 miles long, and it's basically forced line. If you probably heard that term, it's a perfectly straight structure, straight within, flat within, or not flat, horizontal, not even horizontal. It's just straight within 20 thousandths of an inch over 2 miles. And the interesting thing about that, now you can see that it's only horizontal and level at one spot. There's the clue. There's the test. There's the answer that you're looking for. Anywhere
I'm
else,
not
it's not
sure.
level.
Is Slack even level? Is it horizontal at any spot? I'm not sure of that.
I don't have a.
I know it's straight. I know it's straight, but I don't know if it's horizontal anywhere.
I don't think it has a permanent tilt. It might not
you
be
might
very
be right. I
specific.
just don't know.
Well, it'd have to be in the center, wouldn't it?
Doesn't have to be. Could be.
It doesn't have to be. It just has to be straight.
Interesting. Yeah, I guess so.
But I know it's not at a permanent inclination. That's for sure. It might not be exactly at the middle, but somewhere in the middle. It kind
of looks like it's at an angle because it comes down out of the mountains. You know, it's kind of built up against some mountains.
Right. It goes under the freeway under 280 and goes up and down. Actually, they dug into the hill to make it as, it's obviously straight, but as level as possible at some point. And we can, you should go there and do some measurements and see if this idea that you have pans out. It's perfectly straight. You can do all that proof. It's already done. That's why that place exists, because it has to be perfectly straight. And then you can see whether it is level at all spots or if it actually is only level at one spot.
Yeah, and you can probably, I wonder if, I don't know. I'm not sure what the best leveling thing is, but you could compare just how much out of level it is at different places and see if there's a consistent, of course, you'd have to get in first. So.
Sure, we can get a tour there and bring a big 6 foot tall plumb bob or something with something fairly accurate at the 0 point and go along the 2 mile structure and see what you get. And you would find that it's not going to be level everywhere, even though it's perfectly straight.
I would say to what Rob, what you did as well, like what is your margin of error and how much earth curve or how much curve would you expect the water to have curved, and what is your margin of error, and then how did you isolate that to measure a lack of curve between an auto level and a water level between, you said 400 meters?
They are like, I know how big a millimeter is, and it is actually quite large in the scope. You can see a millimeter and the gap between the marks. And if you put your water level exactly in the middle of the 2 marks on each end, and they're identical, I don't see any deviation from horizontal. Therefore, I concluded myself that the water is horizontal. And I could continue that on and use shared straight line segments to keep carrying that on. Therefore, that's why I'm still a flat earther. And
well, so you
if we if we could actually create a horizontal 400 meters long, there should be a 12 millimeter difference at one end.
Well,
But,
yeah, if it was horizontal at one end, right? I mean, as News was pointing out before, you only get a couple millimeters at each end if it's horizontal in the middle. And I don't know how you'd necessarily make it.
And
Yeah.
we've already seen that 1,000 foot, over quarter mile observation of using a theodolite and seeing the 16 arc seconds of deviation. The same size post at a quarter mile away is actually lower.
Got it.
And you say, hold on. If you say it's because of refraction, then you can do tests to see what is the refraction. All you do is just change some angles around, get some elevation changes or some angle changes, and see if the refraction is consistent with bending upward of lightward, because that's what it would take for that to happen. But if light is not bending, you can verify it, which is easy to do. You'll realize that the Earth has to be curved, or there's some other explanation why the plumb lines are angling in for these two objects.
But they'll never make a slab thicker at one end than the other, like a wedge. Never.
You can't pour it because it'll follow the curve. Because that's what we're trying.
Yeah, but what I'm going to say, right? Look, you're going to say like for any building, you have to put down to dig down into for the footings, yeah, for the foundation. That's always going to, like they say, like, oh, you got to go down 6 feet. Usually it's 6 feet, depending, because usually now they'll change the brick structure, or they'll put, I don't know, they'll always put the bricks in, and depending on what the structure is, they'll put the appropriate bricks in. And then, what goes on top of that could be block and beam, or they'll build a slab, which will require shuttering and steel reinforcement. But that slab is always going to be square. So if it's 2 feet at one end, it'll be 2 feet in the middle, 2 feet at the other end. It will never deviate. You won't get one side thicker or the other. So
But the point is, once again, that of course one end will be thicker than the other. You may not be able to measure it, but they won't be the same. That's the thing.
No, that's where you're wrong. Because, like, look.
Well, no, once again, I just have to. It's about precision. You cannot make exact measurements. That's all I'm saying.
And you cannot say that you can't make exact measurements. As much as you
can. I just did, and it's just true. That's just a fact. I'm sorry.
It's not a fact. It's not a fact.
It is a fact. For example, we did this with the theodolite. Listen. You're shooting across the water. We have two theodolites. Try to listen for a second. Two theodolites looking at one another 400 yards away. All right. We look at one to the other to the other. Hold on, forward and back, and we see that the one in the distance, which is the exact same height, with respect to level, is 16 arc seconds lower in your field of view. Why is that? And you can validate that with hard structures if you wanted to.
Right.
But you can't pour concrete. You can't pour concrete because it will follow a curve based on the weight of the concrete being poured and the non-parallel lines of the plumb.
How are you going to, right, if you, like, do you know, you understand how a slab's made and how it's
Did you hear nothing
installed?
You hear nothing I said?
Yeah, you're talking about a light and I'm talking about a slab, and you're telling me about concrete getting poured.
Well,
you don't just pour it onto the ground, do you? You pour it into a structure. Like you'll get the steel. The steel will be fixed, and then it will be like craned in and dropped in, yeah. And then it will sit on podiums. And then what will happen? The shutterers will come in and they will do the shuttering, and then they will pour the concrete.
Let's say you had 100-yard, like a football field, and you filled it with concrete. Would it be flat? Yeah. Would it be flat? You had borders, you had sticks, borders, plywood, you had it sealed off, so it poured like a swimming pool. Now, would that cement be flat?
I doubt it very much. It depends. This is how I said, right? If you poured the concrete, you're definitely going to get a deviation, because, like, the concrete, you're not going to, even if you floated it, you're going to get it as near as possible. But I've seen slabs.
Let's say you did it in 1 foot blocks, 1 foot little sections. You make like you're making steps or stairs or steps.
It's not going to work, is it? You're never going to be able to. Look, the only way to do it is like to to make this, put this, you've got to put steel in. So you put the steel in, and then the shutterers will come in and they will build the shutter in. I've done the shutter in before, horrible job. Then all the boards get oiled, they pour in the concrete, and then the guy will float the floor to try and get it as level as possible. You know, it's like a big, I don't know, it's like a thing what spins around. And that's when they float the floor. Power float, they call it, I think. And that will be the flattest. That will be the flattest you can get it. There won't be nothing flatter than the guy with the power floater. The other guy, if they're trying to put it and vibrate it, you'll have the vibrations anyway, even with the power floater before that goes on. But that's the last thing. They'll power float it, and it will kind of plane it off as level as possible. But even then,
okay, you got it. I got to jump in, dude. Are you done?
Yeah, it's not gonna be level. For sure.
Okay, I hear you. It's just that was a lot of construction technicality that I don't really know if that was on topic or not. But Zanik, was that on topic? Was that even related?
Not really. I mean, I understand his goal, but no, it wasn't related to what I said. What I'm getting at is that you can't do what he's talking about based on the fact that whatever you think is going to be flat will not be flat based on if we live on Earth and if there is a direction of down, which we're proposing there is, and the other side is proposing there's not. So that's not a good test. A good test is to force the line, make a structure that you know is straight, and then compare it with the surface, whether it be the water or plumb line. So there's a two ways.
All right, let me ask you something related to that. So if you had a whole thing of concrete that you let it level due to what level does, so you're saying that would be curved, that a 400 foot meter, whatever it is, however distance would be curved because the concrete would be in a curved path. My question to you versus a flat one. My question to you is could we actually measure the distance of that to decipher the difference between flat or curved? Meaning, let's say you have, however, what do you want to say, a half a mile, quarter mile, even longer than 400 meters, whatever it is. Let's say you have a half mile concrete. Could you, it's just like a question. I'm just asking you what you think of this. Would there be a way that you could take like a line, like a string, and pull it taut and measure the actual distance difference of curved or flat? That's my question.
Laser beam would be better, I think.
Yeah, they don't want to do the optical reflect or deviations.
You could do like laser rangefinders and stuff. Yeah, you could do all kinds of things.
Yeah, use a laser for sure. That would be the best way. That's what they do with theodolites and things. All optical, which is laser, optical, whatever. It's the same thing. The light's traveling through this corridor of air. Or you need to do it like was talked about, floating the neutrally buoyant line on a river, a still body of water that's maybe a mile long or something. And then you're debating whether it's actually floating and you pull it taut and whether it goes down or up, that kind of thing. The best.
I'm talking using distance, though. I'm talking just distance. I know all those things. I'm saying the difference in distance.
Yeah,
I do that a lot
because the string's going to actually have sag in it, so it's going to be a hard thing to
and
actually.
A laser beam also. I think a laser beam's the best way to do it, but at a mile or two, I don't think there's any laser beams that don't spread out to many millimeters, if not a centimeter or something like that. So it's really hard. It'd be very hard to measure the couple of millimeters that we're talking about.
I do that.
But when you talk about using a laser, the way we do like long distance laser shots, which by the way never seem to give the globe result every single time you hit the targets, and lasers go tremendously long distances. Even the ones where they scanned it, they did like 10 mile, then they scanned the laser to the left, 23 miles, and then there's like 3 scans that were all different distances, all just boom, boom, boom. You'd have to have like some kind of a refractive effect that would have to have changed just in that medium to allow it to bend. Anyways, but
highly illuminated light source, and that doesn't.
Yeah, but are you talking about putting if we had a concrete like that, putting a laser right down to it, like a millimeter off, and trying to the same way we do on the Earth? Is that because I thought when you said laser, I thought you meant laser rangefinder? Because I'm talking about the difference between flat and curved and just distance.
Right. Well, a laser beam, technically, of course, will tell you the difference between horizontal and flat and curved. But I think there's still as I say, the problem is that even over 400 meters or so, I think the beam itself will get several millimeters in diameter. So it'll be hard to really know, hard to see the 2 millimeters or whatever it is that you end up seeing.
No, I know, but you're trying to measure the contour with the laser. You're shooting the laser above the surface, the way we do when we do laser tests out on it. Okay, well that's fair. That's fine as an idea. I hear you, and that would have a different set of issues. And I do hear some of those issues you're bringing up. I was just referring to just straight up the distance, like even to the simple level. Like let's say you had whatever the distance is, concrete, it's all level, etc. You then take one string and you pull it taut, and then you measure that string, or you use laser rangefinders, or just get that distance. You don't have to use a string. You use measuring tape. I guess you could use a lot of things to get the really strict measurement. And wouldn't there be a difference if that concrete is curving or whether it's planar?
Oh, I see what you're saying. That would be really minimal. The difference when you're talking about a curve that is curved by a fraction of a degree and a chord of that curve is unimaginably small.
Well, that's why I brought it up. Like, what distances
Yeah.
would we have to do? That's why I brought it up. Like, could it work? What
That's
distances?
not, I think the thing, of course, is to look for the curve itself. For instance, I mean, if you really did have something that you had poured and had really assumed a level surface, that's a little hard to do with concrete, I think, just because of the way concrete is. But if it really was able to do what water does and become genuinely level, then you should be able to like skim a laser over it and kind of see that the laser only illuminates the first portion of it and then isn't able to illuminate beyond because of the curvature. In other words, there's a horizon. In other words, that the laser can't go around. But that would take, a fair amount of distance.
Well, on Earth, we get the reflection of the sun when it's setting. It's right at the setting, and you get that line that goes straight from the sun to your feet.
A little mirage thing, you mean?
Well, it's like a reflection off the water. Yeah, it's a strip of light coming right from the sun.
Right. I think it's a little inferior mirage right at the horizon there somehow, usually.
Well, I'm just saying that's the same idea, though, that the light is running kind of parallel to the ground at that point because the sun is setting, so it's right close to that. And then the light, there's an argument that if it was curved, it would get cut off by the curve. You wouldn't be able to see the sun reflecting off the water.
Well, that's right. Like the fact that at sunset, if you're on the beach and you have somebody else at the top of a big hotel, person at the top will see the sunset later, noticeably later, by many, many, many seconds than you do on the beach.
That would happen on a planar surface as well, but that's not actually the same one I'm saying.
Well, wait a minute. How does that happen on a planar surface?
Well, the higher you go, the more distance you can see, and therefore the horizon distance is going to change. Therefore, the place where it's setting is going to change.
But if the sun is in your line of sight, you're going to see it. It's really bright.
I know, but the difference is that where it's setting is what we're talking about. Because like you said, if it's already starting to set and you go up to the top of a...
But it can't set on a flat plane. It's always above the plane.
Okay, that's now a separate point. I don't know. We're gonna have to stick on one point. That's 3 points all in a row.
I just think we can't even agree on that. We can't even agree on that. A really bright object above a plane is going to be seen by anybody else above that plane. It's not. It can't go behind the horizon.
Of course it can. So this is what I'm saying. It's another topic, though. We're on a third, fourth. It's a bit of a scattergun, but I just feel like we didn't complete any of those previous ones. But that's all right. I guess if you want to jump to this. I mean, originally I was saying that the light reflects off the ground. You were saying, let me just go back to that real quick. The laser, the concrete, your idea is if you had a whole thing of concrete, you put the laser a little bit above it, it would not reach the other end. It would cut off. All I'm saying, because the concrete's curved, if it was curved. So all I'm saying is that on Earth, when the sun is setting, when it's right there, the water is reflecting, or the sunlight's reflecting off the water, and it makes it all the way to your feet. So it's a similar idea. It's like the sun is the laser, the water, the ocean, let's say, is the same as the concrete. And my point is, it has been an argument for years, and I've never really heard a valid one for the globe as to why we get that effect. Why that sunlight, and I'll post it. I think I have one.
I'm confused. I mean, the sun goes. You can, if you simply crouch down at the beach, you can see the sun set, and then you can stand up, and you'll see the sun set again.
Well, this is what I'm referring to. If you look in the chat, because that's a whole separate. That's what I'm saying. There's 3 topics here. Okay, the first one was actually measuring the distance of concrete, and then etc. Then you brought up the laser thing, etc. Okay, and then now we're talking about the laser thing, because we're talking about the margin of error of the distance that would be needed. I still wanted to maybe when Jeremy's in here, because this is actually more in the actual brainstorming because we're going to do all these tests. So the next 2 decades, the next 1 to 2 decades, we're going to do all of these things. So I guarantee it. So all of these will be tested and etc. But nonetheless,
you do agree that on
the final experiment was not the final experiment. Just
Okay.
remember that.
Now let's
So
have
these
some
are a
more.
bunch of topics. We have to just pick one because the first one, let me just real quick. The first one was that concrete one. You mentioned the laser. Now I'm mentioning this light reflecting off the water. You then talked about sunsets. And then I think there was a third one in there. So we just have to stick on one is all I'm saying.
Well, let me just be clear about, I mean, I think the laser test on the concrete, assuming you could actually make it level, if level meant flat, then you could do this laser skimming across the top and it would just skim out there to an arbitrarily large distance. Assuming the laser was, above the surface by a millimeter, then the laser beam is going to illuminate a line going on forever until it gets too dim to see. But that's not the case, of course, if it's a curve. If it's a curve, there's a horizon.
No, I hear you. And originally, it wasn't even my idea to do a laser test on the concrete, although that is interesting as well. It was more measuring the distance, but I do hear you on that.
I'm going to post a picture in the
I
chat.
just posted real quick too. Like, we're jumping topics a bit here, but just let's move on from the laser one for a second if we want. But just since we covered this one, do you see the last two images I posted? So not even in a debate fashion, but it's related to the laser over the concrete is why it links to it, of course, because it's kind of a replicated, on a larger scale. So I'm just like, not even in a debate thing. I'm just curious, what is your explanation for that?
Yeah, well, that's pretty simple. I mean, when you look at so the curved surface, right? The third, or I guess it's the top part of the second thing you posted. That's a smooth curved surface, and so it does a specular reflection of the sun. You get an image of the sun that'll be distorted like a funhouse mirror and distorts any image. But that's not what happens over the ocean. The ocean is not a smooth surface. It has ripples on it. It has pieces of the surface that are at all possible angles. And so in any given region, there'll be some parts where the surface doesn't reflect the sun into your eye. Those are the dark parts at the top where it says how light reflects. The dark parts are places where the surface isn't reflecting the sun into your eye, and the really bright spots are the parts where the surface happens to be at just the right angle to perfectly reflect the sun into your eyes. And in between, because you have ripples of all sorts of sizes, you just get a general bunch of light being reflected. For any square meter of the surface, there's going to be a part of the surface that reflects the light into your eye. If the ocean were a smooth surface, then you'd see an image of the sun. And there are pictures of lakes where you see that, right? If the lake is still, you see an image of the sun, not a bar reflection line like that.
All right, but here's the difference though, is that everything you said there. I understand the general ideas of the reflecting light. That would happen over a planar surface. You're going to have reflection, but all that would be on the water, though. It's not going to. So what we're seeing here is the reflection on the water, but the thing is here, though, is that I understand the idea of light going across, let's say, a planar surface, that you would have the light reflecting off the waves and things, but the waves are pretty small. We don't know how big those are.
They don't have to be big. They just have to angle by 1/10 of a degree or something. We're not talking about big angles there.
But the issue is that there's not a straight line shot from, let's say, your feet on the beach to the sun if it was a globe. That's the issue. The reflecting is fine. Like, the issue is that if you have, just like we were saying with the concrete thing, if you had curved concrete and you put a laser, on it, it's just gonna shoot off into space. Basically, it's gonna shoot off the concrete off the curvature, and therefore not be able to light the other side of that hump. You know what I mean? Like, it's shooting up off into space. Right. It can't curve around. So the thing here, that's what's being questioned, is why there's a straight shot. And of course, over a planar surface, it's because it's straight and level. Over a globe, that shouldn't happen. Like, the light should be just like from the sun, especially when that image shows the sun a little above the horizon. Really, when it gets, because that reflection happens even when it's the last slither of sunlight. You know what I mean? The last bit, or the sun. When it's setting, it will still light that all up.
Right, because you still have all possible angles on the surface of every part of the water. So you're going to get light.
But just like the laser shoots up off into space, this sun should be going, hitting the curve and being blocked by, if it's many miles away, it could be hundreds, thousands of feet or more of curvature. So the whole sun path should be blocked by the curve. That's the issue.
The time when it's blocked will be after the sun has set.
if you can see the sun, then there is sunlight that is hitting all the parts of what you can. Well, I just have to think about that for a second. Wait a minute. No, I do have to think about this for a second. I mean, the problem is that you do have to be clear that you're seeing it with the same eyes, right? So if that sun is illuminating the surface, then you're going to see reflections from that surface. There ought to be, I guess, a small
John,
if you're like
can I
up
for
at
a
the
second?
top of a hotel, there ought to be a time when looking down at the water, the sun is no longer illuminating the water right in front of the hotel and the beach. And so you shouldn't be able to see the bar all the way to the beach. You should only see it to the part of the water where there's sun actually hitting it still.
No, that's something different because the sun has set, but I hear you on
John,
that too.
John, can
Go
I
ahead.
for a second?
Yeah.
Okay. So first off, in the picture, you know, done to scale, you would be standing on the top one. You would be standing directly in front of that light, way before the first black block.
Wait, I'm sorry. Let's make sure we're on the same page. Which one?
The second picture that says curved surface, flat surface, real surface.
All right, let me. I think I might be able to tag it to the chat. So hold on.
I'm looking at it right now. Yeah.
Yeah, and I think it's really important to keep in mind that's a smooth surface in the thing you're pointing to. That's not what water does.
All right,
John,
this is the one we're talking about. Hold on,
John. Yes, that's the one. John,
Okay.
He's making two arguments. Okay, so the first one is about distortion, which I agree is it's going to be different. Or
Hold on, you're breaking up.
Non. Okay, so the difference between
hold on, you were breaking up, and you got to start over. And then are you talking about me here? You're saying these are my arguments because I want to make sure I'm not strong man if you're talking about me. But you were breaking up too because it's
okay.
not distortion. I didn't say the word distortion, but anyways, go ahead.
Yeah. Okay. So no, if you posted them, I thought they were your arguments. But if they're not,
I was posting it to elucidate. I was posting just the imagery to elucidate the points that we were talking about. The point we were talking about. Yeah.